Welcome everyone to a new video. So in this video we are going to be talking about Barton reaction, which is one of the prominent reactions of radical chemistry. And before I start my video, I would like to request you guys to like, share and subscribe to the channel, and most importantly comment on my videos and let me know about the type of content I'm making. If you wish to see some improvements, let me know about it, and if you want me to cover some other topics, let me know about it. I'll make sure I post those videos, and because my only aim is to make sure the students get a very good rank in net and gate exam. Okay, so let me know about my content. And so in this video, okay, so in the last video we talked Hofmann-Loffler-Freytag reaction. So in that case we said when we have anhaloamines and when we irradiated the acidic solution of anhaloamines, we observe a formation of pyridine. So इस केस के अंदर हम क्या करते हैं, इस केस में हम क्या करते हैं, हम ऑर्गेनिक नाइट्राइल से स्टार्ट करते हैं और उससे हम क्या बनाते हैं, हम नाइट्रोसो कंपाउंड बनाते हैं. ठीक है, इसी रिएक्शन को हम कहते हैं बार्टन रिएक्शन. ओके, फोटोलिटिक कन्वर्जन ऑफ ऑर्गेनिक नाइट्राइल्स इनटू नाइट्रोसो कंपाउंड इज नोन एज द बार्टन रिएक्शन. और इस रिएक्शन का इट हैज फाउंड अ ग्रेट यूज इन द स्टेरॉयडल केमिस्ट्री, क्योंकि हम स्टेरॉयडल केमिस्ट्री काफी ह्यूज आर्किटेक्चर्स है. और as I said, here we are talking about oxygen centered radical. So in the last case Hofmann-Loffler-Freytag reaction के अंदर we were talking about the nitrogen centered radicals. First of all, nitrogen centered radical generate hota and then it is transferred into the onto the carbon centered radical. So here as well, first of all there will be a generation of carbon the centered radical, and then through remote functionalization it will be generated at the delta position, exactly similar to what we saw in the previous case. So what happens actually, we have this organic nitrates. When you heat them or irradiate them, then there is a cleavage of this bond takes place with both of them take one electron each, so they form the alkoxy radical and nitrogen monoxide. उसके बाद as I said, intramolecular hydrogen abstraction होता है, which is from the delta position, absolutely similar to the previous case, and it leads to the formation of this nitroso alcohol, which may be isolated as dimer or rearranged to oxime. मोस्टली वो ऑक्साइड में रीअरेंज करता है. बट रिमेंबर दिस थिंग, लेट अस सपोज इन केस समवन आस्क्स यू how can nitroso alcohol be isolated, always remember it exists as a dimer. So now we are going to look at the mechanism of this Barton reaction, which is very useful. So if we look at the mechanism of the reaction, what do we start this from an organic nitrile. So when we irradiate it, as I said, दोनों के दोनों अपना एक इलेक्ट्रॉन ईच लेके साइड हो जाते हैं. एंड इन द नेक्स्ट स्टेप यू हैव दिस अल्फा बीटा गामा डेल्टा. whenever you have this delta hydrogen present, then there is a formation of 6-member transition set. So all these remote abstraction by oxygen radical or by carbon radical or by nitrogen radical, they takes place via 6-member transition set. So we can also represent this in the form of the chair conformer के अंदर भी. ठीक है, so abstraction will lead to the formation of carbon radical. So as soon as this carbon radical is formed, so it attacks the nitrogen monoxide to give you this nitroso compound. Now this is what we are saying, this nitroso compound then rearranged to give you the oxime. So you can clearly imagine this is one of the best method for the preparation of this nitroso compound or the oxime. And you can clearly see we have absolutely activated the delta position, which is far away from the actual center where the reaction is taking place. So this can be regarded as one of the very better examples of CH activation. Now here I have represented an example. This is a very important example which is a very high probability of being asked in the exam. So we have a cyclic system in which we have an organonitrile. So whenever you see an organic nitrile and you see heat or radiation, always just keep in your mind that we are talking about Barton reaction even in the exam. So we have this alpha beta gamma delta position and we have अल्फा बीटा गामा डेल्टा. नाउ अगर आपका यहाँ पर वाला आपका रेडिकल जनरेट होकर रिएक्शन होता है, would have got a bridge system which is much more strained. But in this case it happens at the delta position. What do we end up getting is the oxime. This is the oxime that we end up getting. Now what he has done, he has used the tosyl chloride and pyridine. So what happens, this undergoes tosylation, and then under the same condition the Beckmann rearrangement takes place to give you the ring expanded product, and this is the what you end up getting. So this is a very important example that has a very high probability of being asked in the exam. Although This reaction is very very low yield. So let me tell you something about the free radical, or whenever you carry out a reaction in presence of light or radiation reaction. This is the reaction product that we observe. Apart from that, there are many other pathways these radical form, these radical undergo, because radicals are very very reactive and they give you a number of side products. So sometimes it is very very difficult to exactly predict the kind of product that you are going to obtain. Okay, now we can see that, okay, apart from the generation of alkoxy alkyl can undergo intramolecular hydrogen action, can be achieved by photolysis of hypohalides. Okay, so what we did so far, what we took was the organonitriles. So instead of the organonitriles, if we use the hypohalides can be used, and if we irradiate these hypohalides, what do we end up getting? 1,4-dichloro alcohols, which can be transformed into THF. So this is probably one of the best methods to convert these hypohalides into tetrahydrofuran derivatives. So if we see, what do we mean that? Now initially बार्टन रिएक्शन के अंदर हमारे पास क्या था? ऑर्गेनोनाइट्राइल था. यहाँ पे हमारे पास क्या? हाइपोक्लोराइड, हाइपोहैलाइड्स है. जब आपने इसको इरेडिएट किया, देयर इज अ क्लीवेज ऑफ दिस ऑक्सीजन एंड क्लोरीन बॉन्ड टेक्स प्लेस. ये दोनों क्लीव करते हैं. और what is the reason why this bond is getting cleaved? It is very interesting. Since whenever you have two electron negative atom attached to each other, so they try to pull the electron density towards each other, towards itself. क्लोरीन अपनी तरफ खींच रहा है, ऑक्सीजन अपनी तरफ खींच रहा है, जिसकी वजह से जो बॉन्ड स्ट्रेंथ है इसकी बहुत ज्यादा वीक हो जाती है. एंड दैट इज वाई in presence of light or under extreme heat conditions, it undergoes cleavage to give you the radical. So once the radical is formed, again there is an abstraction from the delta position to give you this carbon radical, which is then captured by the chloride radical to give you this 1,4-chloroalcohols. And now if you use some kind of a base like NaOH, then it will cyclize to give you tetrahydrofuran derivative. So you can clearly imagine this is one of the better methods. But इस वाले reaction की एक problem है. There is an issue with this particular reaction. The issue is that if the reaction cannot undergo 1,5 hydrogen abstraction, जैसे इसे हम 1,5 hydrogen abstraction कहते हैं, then इसके अंदर there is a competing beta cleavage that is taking place, जिसकी वजह से आपका carbonyl product इसमें बनता है. So what happens if you are dealing with a substrate like this? Okay, and on carbon cleavage, this radical, if you do not have any gamma proton, then this radical has a high tendency of coming back and forming a aldehyde type of species. And then you have this alkyl radical generating, which is captured by chloride. So such type of products can also be obtained. So this is a very very important example, and I feel you should keep this example in check. And there's a very high probability of being asked, because here we are getting the product as a result of the beta cleavage. Now we are going to look at three very important examples. So in the first example, again what we are using is iodine iodobenzene diacetate. As I said, this is probably one of the mildest method for the iodination. So what we are forming is that we are forming OI bond, just like hypohalides. We are forming hypoiodides. As a result of formation of hypoiodides, what it does, alpha, beta, gamma, delta, it results into the cyclization of this methyl group. So this is a very very important example. Just keep this in mind. There is a formation of tetrahydrofuran derivative. Apart from that, in this case, we have these benzyl protected alcohols. And what happens in presence of anidosuccinamide in under irradiative condition? It is cyclization with at this position take place. So this free alcohol, it undergoes the formation of hypohalides, and as soon as hypohalides forms, there is a formation of oxygen radical, and then alpha, beta, gamma, delta. So this position gets irradiated to give you the cyclized product. So this is also a very very important example. And in the last example, we can clearly see that when we are trying to irradiate this compound, then we can clearly see this gamma position. This is clearly, it does not have the hydrogen. So what I said, when you do not have a site which is available for gamma abstraction, then the only option the reaction have is a beta cleavage. So this substrate undergoes beta cleavage to give you the lactone. I'm sure you can write down the mechanism. The mechanism is the formation of OI, then there's a generation of radical over here. As a result of generation of radical, what you have is the opening of the ring, and you can just simply write down the mechanism. It is a very very fascinating mechanism. But all these three examples are very very important from exams point of view. So this was about the Barton reaction. Let me know about the video, and comment on the video. If you have any confusions, let me know about it. Okay, so subscribe to the channel. Thanks a lot for watching the video.